Welcome friends. In the last lecture we had discussed about the voltage measurement using a digital multimeter, and in the same sequence we are going to learn about current and resistance measurement using digital multimeter. So the main points we are going to discuss today are the measurement of current using digital multimeter, measurement of resistance using digital multimeter, and the working principle of a digital multimeter as a whole. So let us start with the current measurement using digital multimeter. So the basic range of the current measurement that we use in digital multimeter are first 0 to 10 milliampere, second 10 milliampere to 100 milliampere, third one 100 milliampere to 1 ampere, and the fourth one is 1 ampere to 10 ampere. So these are the four different ranges which we use for measurement of current using a selector switch. So we can measure the current by different means. There are two especially techniques used in digital multimeter. The first technique is the current is flowing through a resistor. So I have a current over here and I can use a digital voltmeter to measure this current. So this is one technique by which we can measure the current by the means of a digital voltmeter. And the second technique is the conversion of current into frequency. So let us see how it works. So for this, the elementary circuit that we can use is an op-amp in integrator and comparator mode, as we have discussed in previous example also. So the inverting input is given a feedback through a capacitor. So I have to integrate this capacitor over time. Then here I am giving a current source. A current source is there. So we have the non-inverting input. This can be grounded, and the output of the integrator is giving to a comparator. So minus plus. So the non-inverting input is again given a negative reference voltage minus Vref, and the output of the comparator is basically the output of the circuit. So this output is fed back using a pulse generator. So you have a pulse generator over here. So pulse generator. Now this pulse generator is used to send a grounding pulse or a pulse that can discharge a capacitor. So as we have discussed earlier, how the integrator circuit works when the current flows in. So this input is very high impedance, so the current will try to flow through this path. The use of the other path is different. Let us discuss about it little later. So initially when the current is flowing, so capacitor is charging like this. This negative voltage reaches beyond a limit where it crosses the minus Vref voltage. In that situation, the comparator output will observe a change of polarity in the negative direction. This change of polarity will definitely trigger the pulse generator, which will send a train of signals that can ground the charge over this capacitor. So this will provide a grounding circuit in that case, like this. So you have to charge and discharge the capacitor over and over again depending upon the magnitude of the current, because more is the current magnitude, the capacitor will be charged fast. So we can see that more is the charge on this capacitor, faster will be the reset of the pulse generator. So at the output, a frequency will be generated, because the capacitor, if higher magnitude of current is applied, will get the charging voltage for this point in a less time. So we have the current, suppose we have the current over here. So more and more current is given at the input, less is the time to charge the capacitor. So faster will be the triggering of the pulse generator each time I am applying a new current sample to charge the capacitor. So we can understand that the current magnitude will be converted into the frequency of the output voltage of the comparator. So the output voltage of the comparator will have a frequency which will be proportional to the input current I. That is how a current to frequency converter is used for this purpose. So our next topic is the measurement of resistance using a digital multimeter. So for measurement of resistance, again we will go for a circuit through which constant current is applied. So we are going for a circuit here. We are going for a circuit with constant current source. This current source will charge circuit. So basically the current I will flow this circuit. Current I will flow through this circuit, and we have a ground over here, and we can take the voltage output at this point. This is again sent to a attenuator, and attenuator before the sample and hold circuit, and A to D converter is made to count the input magnitude. So this is the A to D converter. So the output will be a digital output which can be displayed or recorded, or it can be recorded. So here actually the output voltage proportional to the current is taken in and converted to the output. So naturally I can understand that if the current is fixed, then according to the resistance inserted, we will have a proportional voltage. So output of the converter, this digital output, is calibrated to the resistance which is applied for measurement. Here we use a voltage source with very high resistance, so that a constant current can be produced to make the circuit work more precisely. So we have a voltage source with very high current, high resistance to produce a small constant current source, and this constant current will be able to generate a digital output which is proportional to the resistance to be measured. So with our previous knowledge of attenuator, sample and hold circuit, A to D converter, display, we can very easily figure out how resistance can be measured using DMM. So if in the exam the question comes and it is of given marks, accordingly we will take a decision how to explain about the circuit. If it is a 10 marks question, then you have to explain about attenuator, A to D converter, SNH circuit, and the display and the latching process, start bit, everything in detail. But if it comes as a 2 marks question, then this much a small explanation is more than enough. So let us now understand how the DVM is encapsulating all this in one unit. So here in the DVM, actually, let me draw the circuit first, then we'll discuss how it works. So first we have attenuator. Attenuator, I'm writing in short for the sake of saving time. Attenuator. This is again attenuator. So you have a switch, input switch, 3 inputs I am considering at this point of time for the measurement of AC voltage, DC voltage and current. So you can have more input depending upon the requirement. So if you are going for AC measurement, you need to rectify. So you have rectifier and filter. So this output is again going to a switch. This output is going to a switch, and this output is going to a switch, and we have the third switch which is using a resistor and a ground, and we also have a fourth switch which will be taken to the output directly. So here I have three different kinds of inputs to be measured. So I can draw like this, 3 different kind of inputs to be measured. This is 1, 2 and 3, and like this we can switch between the inputs, and the third one is the DC current source for measurement of current. So here I have mentioned about this. So this is for measurement of current through the DVM technique. So you are using measurement of, this is for current measurement. Second one is for DC voltage measurement, and first one is for AC voltage measurement, AC volt. So here accordingly the second switch will also work among these. This will switch, this will toggle like this, and so when this is at 1, you can go to 1, it is at 2, you go to 2, it is at 3, you go to 3, like this. So now we have here the 4 points, 1, 2, 3 and 4, and all this will go through a switch. This is again a toggle switch. We can toggle between the different selection options. You have A to D converter, and this can be either displayed, display, or recorded, recorded. So we can go like this, and now let me explain how it works. So this is schematic diagram shows a basic digital multimeter circuit. So when you switch over S1, S2 and S3, so the coupling with the next circuit, that is the middle one through attenuators, if one switch jumps to position 1, the other switch follows it. So accordingly we have the selector switch as you have seen in the digital multimeter. So the individual circuits for AC voltage, DC voltage, current, and similarly other parameters like resistance can also be measured. Even we have measurement options for inductance, capacitance also. So the basics have already been discussed. In this lecture we have discussed the current and resistance, and earlier lecture we have measured about voltage. So this digital display can actually generates 3.5 digit digital output ranging from minus, so we can write like this. So here we have a range of minus 1999 to plus 1999 can be displayed, and 3.5 digit display is there. 3.5 digit display. This means you have three digits from 0 to 9, and one digit for 0 or 1. One digit for 0 or 1. So we can use the MSB digit for polarity. This way the basic digital multimeter circuit works. So if the construction and working of a digital multimeter is asked in the exam, so you can draw this circuit and explain the basic concept. Again, depending upon the marks, whether it is a 3 marks problem or a 10 marks problem, you have to explain the parts separately. So if it is bearing more marks, then you should explain the resistor, measurement of voltage, AC and DC, then current, as well as resistance measurement in detail. So friends, this much is the detail that we plan to discuss today, and in the coming lecture we shall discuss the measurement of frequency using digital techniques. So this is the textbook by Professor A.K. Sohane. It is a huge handbook and bibliography of measurements and instrumentation. Most of the topics are covered over here. So today's topic has been taken from the same textbook. The digital support which we are using for this lecture are the Microsoft Whiteboard for Windows 10, and all the writing work and drawing picture are done on this tool. So if this lecture is useful for you, you can like it and subscribe the channel and set the bell icon for further video updates, and you can write me queries at emmifaq@gmail.com. So thank you for your patient listening.